Welcome to the Analytics Engineering Podcast, featuring conversations with practitioners inventing the future of analytics engineering.
On this episode, Tristan and I sit down with Bob Muglia. Bob likely needs no introduction. He's well known for being the former CEO of Snowflake during the early transformational years of the company from 2014 to 2019. He took a risk joining the company when they were pre-product and pre-revenue as the 34th employee after a long successful career at both Microsoft and then Juniper. Bob is currently investing and advising startups in the data ecosystem, including established companies like Fivetran and up-and-coming ones like Pinecone, Relational AI, and Julia Computing. He recently released a book called The Datapreneurs, which talks about the arc of innovation in the data industry, starting with the first relational database, all the way to the present craze of LLMs and beyond. I was really excited to have Bob on the show because he's an absolute legend in the industry and has some really interesting stories of how enterprises adopt and respond to early innovation.
I don't know how many times you've gotten to hang out with Bob, but I have had the pleasure of getting to know him over the course of the last several years. Bob was one of our very early angel investors. And he's the only angel investor that said to me, I don't know how you're going to make this thing a business. I was like, Bob, I really appreciate your transparency. Let's talk more about that. But I never know what I'm going to get when I show up to a 30-minute meeting with Bob. But every single time I have ever spent time with him, he connects new brain cells for me. And so this was no different.
Yeah, he's a really interesting thinker. Like he calls himself a plumber where he can go really, really deep into the tech and how it works. But then he also calls himself, I'm the businessman. I'm not the technologist. And then he can go from really kind of detailed thoughts about product and company all the way to, we got into some out there stuff with AGI as well. So his versatility is really just impressive.
There's one area that we may have to follow up on in another podcast. And if you're listening, you'll hear Bob start to talk about the relational knowledge graph. And that is a concept that I did not at all understand when I first heard Bob talk about it. And we were not able to go deep enough here to really get into the nuts and bolts of it. But there is a there. I have convinced myself over the last, 18 months of spending time with Bob and a couple other folks that there is something interesting there. And I felt bad that we didn't spend more time on that here because I think that could be a 30-minute conversation all by itself.
Yeah, he definitely kind of coined the term business engineer and how we're going to maybe move much more into, instead of thinking about people moving bits or the exact process to get pipelines working or the exact process to do the analysis, that will be left up to the machines and to software to solve that problem. And I think the knowledge is what humans bring to the table, and how do we encode that to work well with machines is super interesting.
100%.
I think this is going to be a really great episode. I hope you enjoy. And a final note, it's great to be back recording for season 4 of the Analytics Engineering Podcast. If you like what we're doing, please drop a review, share with a friend, and subscribe. We're lining up a great set of guests for this season. And if you have suggestions, we want to hear from you. So without further ado, let's get into it.
Bob, thank you so much for joining the podcast. It's great to have you.
It's great to be here. Thanks, Tristan.
There are many of our listeners who will know you through their experience of Snowflake, but I thought that we might go back a little further to start. Your LinkedIn says that you worked at a little company called Microsoft, and it says that you spent a little bit of time there. Can you just tell us about your experience there and what kind of stuff did you get up to? What era? What was happening at the company when you started there? I'd love to dive into some of the history.
So I joined Microsoft in 1988, January of 1988. So it was pretty early. They had just gone public. They went public in 87.
That was when you went public straight out of the garage, right?
Well, they had gone public and they were already not really. We were in buildings 1 through 6 then.
Okay, all right.
Old, I don't know if anyone remembers the old XX buildings that Microsoft used to have. They've all been torn down now. They've replaced them all with fancy new buildings. But I was in the old campus that they had built. They'd already to the campus, about 2,000 people. about 100 million in revenue, give or take. DOS was the biggest product by far. I joined to work on SQL Server. I was the first technical person on SQL Server, and my role was what Microsoft calls a program manager, which is really like a product manager, but more focused on the delivery of the product than a traditional definition of a product manager is.
That's really interesting. I did some like very lightweight web development right around the year 2000, and I used SQL Server to do that. But I had gotten the sense that SQL Server was newer than a decade old at that time. Did it take a little while?
It started to work. It took a while to make it work on Windows NT. When I joined, we were running SQL Server. The goal was to put SQL Server on OS/2 because that was the technology that we had been working on jointly with IBM on at the time. And we were working with Sybase. I actually worked with our partner Sybase, and it was still a Sybase OEM product at that time. A couple of years later, we changed our relationship with Sybase and actually took control of the code ourselves, essentially let Sybase free and Microsoft free, and we both had the ability to run in our own directions. And then that was the point where SQL, the first versions of SQL, that Microsoft built came together. I think SQL 7 was a key release, if I recall correctly. And that was the mid-1990s when that came out. And at that point, that was mostly Microsoft code inside that technology. And it really was a truly revolutionary product for the time period because it ran on computers that were much smaller than SQL databases were typically running on at the time.
Not that anything I did in this era is at all interesting, but I remember talking to a bunch of like longtime Oracle people in like the very early 2000s, and I would share my positive experiences with SQL Server, and they were shocked that any other database had replicated some of these Oracle features. So it was like very much like an industry-leading transactional database even back then. Over the course of your career, you started in databases. Have you been doing databases throughout?
Yes, but I've also done many other things. When I was at Microsoft, I was sort of a pinch-hitting player that would go into organizations that needed transition in some form and would work on them for a few years and then typically would move on to another role. So, I started in SQL Server, but then I shortly after that became the OS/2 program manager, and my primary role there was to kill it. Now, I wasn't, I was part of the firing squad, but I didn't really fire the gun. To be fair, it was senior management at Microsoft that really did that. So my boss, Paul Moritz and Bill and Steve really made those decisions, but I was very much involved in the transition to Windows NT and then ran the Windows NT program management team. After that, I spent a little bit of time. I took on Visual Studio. Actually, in 96, I was running that team, and that was the year we created Visual Studio. It didn't exist before that. And my job was to make the C++ team and the Visual Basic team, which were fighting like cats and dogs. They mostly fought with each other to work together in one way. And that's the creation of Visual Studio that really did that.
Were you involved in .NET?
Yeah. I mean, I was the poor dude that signed the Java contract for Microsoft. So I was the one that went to court, and dealt with all of the court cases on Java, including the Silicon Valley court case with Sun. And I was the primary witness for Microsoft. Wow. And then I also played that miserable role in the DOJ trial that came shortly afterwards. I often say at Microsoft, I saw the good, the bad, and the ugly. And that would be the ugly. I was very involved in the antitrust work that happened in the early 2000s. And in fact, in like 2005, I was traveling to DC once a quarter to meet with Kohler Catelli and the DOJ to help dig us out of a protocol documentation hole that we had dug ourselves into. So, Microsoft's amazing. It's been such an amazing job of becoming a responsible company. And I think many of the lessons that happened in that time frame helped to teach the senior executives of the company an awful lot. And it's really quite impressive to see how far they've come.
So I can already tell this is going to be one of those episodes where an hour is just not nearly enough time. But I want to flash forward to maybe 2014. That was a big year for you after over a couple decades at Microsoft being an executive. You took a really big leap of faith in this very small upstart, Snowflake. You joined as employee 34 as CEO. And at the time, the company was pre-revenue, maybe early product. was how you described it in your book. What attracted you to Snowflake of all opportunities to go really at the ground floor to start building it?
Well, I had left Microsoft in 2011 and I joined Juniper in the Bay Area. And that was very helpful in the sense that it established I was able to establish a presence reestablish a presence in the Bay Area because I was originally down there before I joined Microsoft. My wife and I were both lived in Silicon Valley before we moved up to Seattle. And being down in Silicon Valley was helpful. And one of the things that was obvious to me was the cloud was changing everything. And there was enormous opportunities that were going to be created from the cloud. They were all over the place. I came to the conclusion that I wanted to do something small and run a smaller company because I felt like I had been doing this work of creating things, building things. And that seemed like a good place to do it. I learned over time, there's really two kinds of managers in this world, in a simplistic sense. One is people who like to fix things. And maybe there's three, because there's maintainers too, but we'll put that aside. There's people that maintain, there's people that fix, and there's people that build. And I spent a lot of time trying to fix something when I was at Juniper. And I decided I didn't enjoy that as much and I wanted to build something. And so starting at a small company would be a great way to do it. And when I first met with Benoit and Terry in, I believe it was late April of 2014, I realized they told me what they were doing and how they were building it. And I realized that if this product worked, it would be very much a game changer because of the fact that there were so many constraints in databases and Snowflake had the potential to eliminate those constraints. Now, to be fair, the product didn't work at that time. It really was. The revenue was exactly zero. We had about 4 or 5 beta customers that were working with the product, but they were just really playing with it.
When's your read on when it got good, like good enough for production use cases?
2016, really. I think it took a few years. This sort of meme that it takes 5 years to build a SQL database, it's just really true.
I think it's 10.
Well, it's 5. It isn't 10. 10 gets a whole thing out, but it really does take time. It really, really does.
If you're involved, it takes 5.
Well, I think Benoit and Terry are involved. They wrote the code. They're the brilliant ones. Give them all the credit for it. And the reason, by the way, is those guys were there till 2 a.m, day after day. They were the first ones in the office and the last one to leave. And you'd see them and they were writing code. Yeah, there's a lot of work.
So you saw something special. You're like, if this works, it could be enormous. But you had that belief maybe before the rest of the market did. Cloud was very new. You had high conviction that databases should be run in the cloud because there are all these efficiency and scale out benefits. But the market wasn't quite there yet. I think in the early days, enterprises were really wary of moving data to the cloud. In your book you just released, there's a funny story you share about going and pitching Goldman Sachs. And they kind of laughed you out of the room and they asked, when would you build something on-prem? And you said, it's not going to happen. I predict that you'll move to the cloud before we build anything on-prem. When did the dominoes start falling in the market where enterprises got comfortable with moving data to the cloud and that became the preferred deployment model?
Slight correction, it was Benoit that said all that. It was Benoit did that meeting.
Okay.
That was there. Just to put the credit. Give the credit where the credit is due because it was Benoit's sort of vision. And it's one of those, it's actually in the Snowflake lore that meeting happened. And I would say it depended on the enterprise, right? So at first, our first customers at Snowflake were customers that had a lot of data on the cloud, but did not have a lot of regulatory issues and their privacy concerns were less, which meant the categories of customers were marketing, advertising, online gaming. Those were our first customers, which have somewhat less. Their requirements for security and compliance, while very much present, were not nearly the same level of concerns that a financial organization would have. And so our first customers were really in that category. People had a lot of data. Often they were working with semi-structured data. And if you go back to 2014, 2015, that was a misery for people. They had massive amounts of data being thrown off by internet cloud-based systems. The only tool they really had to work with at the time was Hadoop, which is a beast. Very difficult product to manage, and very few customers were successful at deploying Hadoop and getting strong, getting good results from it. And so we were able to go in and find, customers that had real data problems and they couldn't solve them. And then Snowflake was almost a miracle to them because it solved the problems in a way like nothing else did. The two places at first were, like I say, these semi-structured customer sets. And then the other case that was really important was Redshift, because Amazon, did amazing things. I mean, I give Amazon so much credit for the cloud. I mean, they paved the roads for the cloud, but they also paved the roads for the data warehouse in the cloud, because they released in 2012 a decent product, not a great product, but a decent product, Redshift, which works actually quite well until it hits a scale limitation, at which point it starts working very poorly. And, what we found was that many, our first customers, many of those customers were Redshift customers who had hit the wall and needed an escape hatch, and Snowflake was the escape hatch for them.
I remember when we were in our consulting days, the early Snowflake reps would just buy me lunch and they'd say, what customers are you working with that are on Redshift? That was the playbook. While we're talking about cloud, and I think all three of us are cloud people here, and so, but I want to play devil's advocate for a second. I don't have the timestamp on this article, but I was just linked to an article that one of our mutual friends, Bob, wrote, Martin Casado at A16Z. He wrote this really interesting piece on cloud repatriations. So I think Dropbox is probably the most notable one of these, but I think they kind of went all in. They pulled really a majority, if not all, of their workloads back from cloud to their own data center. But there's a lot more companies that have gone kind of pulled select workloads back to on-prem. And the argument that this post makes is that there's simply, by purchasing from a cloud vendor, you are subject to their markups. And sometimes their markups are very high and sometimes they're just high. And so this perspective is it makes sense to start on the cloud, but it's not always clear whether it makes sense to continue indefinitely on the cloud once you hit really large scale. Now, again, I'm a cloud person. dbt is built around cloud data warehouses, so I'm not really trying to take a strong stance here, but I'm curious if you have any thoughts on how far do you scale in the cloud?
I think the biggest distinction here, and I think this is largely correct, is that the workloads that people have decided to bring back on premises are operational in nature, not analytic by and large. I don't see anyone moving analytics back on premises. I mean, if you do, we should talk about that.
What do you think makes those two things different?
The variability of the dynamic nature of the compute load. See, in an operational workload, you have a relatively static compute load that you have to put against it. And that may not be true in the serverless world, blah, 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 the way the world's going. But certainly in a classic enterprise application, the resource requirements are very predictable up front. And the operational constraints are also predictable by and large. So you can say, hey, this is what it's going to cost me to run this on premises. And for whatever reason, maybe it's security reasons that I have, maybe it's just that I think I can run it better for some reason, I might choose to do that. I treat Dropbox as a special case, okay? Let's take them as a special case because they're a very, very storage intensive app.
Yep.
You could easily imagine how Dropbox could get better economics by running their own data centers. Now, a really interesting question is, could Snowflake get better economics?
Yeah.
Could Snowflake offer a region that's a snow region? Okay. I have no knowledge of this. Let me first by saying I have no knowledge of the insides of Snowflake, but we always thought that was possible. That you might have it, that the economics could be such that it could make sense. But it's pretty, you don't exactly have to pour concrete, but you come close to pouring concrete, right? And the other thing that's challenging, when you think about this is by and large is the capital expenditures right now are just insane. I mean, for these cloud vendors, just insane. I mean, you're talking about tens of billions of dollars a year in capital. The new money that's going in is, into these GPUs. And, I'd say a large percentage of the power in dollars that's being spent by the cloud companies in 2023 is to power NVIDIA GPUs. And that's a whole new world too.
I remember reading that article when it came out. It was a couple years old, Tristan, right? And the cynical part of me thought Martin was trying to push his open source portfolio that largely sells on-prem. But I think you have to have an enormous to even consider moving off of the cloud. And for the 99.9% of use cases, cloud just makes sense. But it was interesting. I remember back in 2016 when Bob, I used to be in venture, and we backed early companies that were in similar spaces. And I remember people in venture being pretty cynical about Snowflake being an independent company and being able to go head to head with the cloud providers.
I remember too, because I got a lot of no's.
And I distinctly remember some very senior partners, like, quote, I remember them saying it, like, they'll never be able to compete against AWS. It's just not possible. And then boom, Snowflake exploded. How did that happen? Because wisdom would say like distribution trumps product 9 out of 10 times. And what I'm hearing is like Snowflake's product was really a step function better than anything else. Was it just that? Or how did you end up competing as an independent?
It was certainly based on the product. Let me just start. I think it's always based on the product, Julia. I mean, if you ask, and talk to any of the CEOs I work with, it's always about the product. You have to have a great product because ultimately that's what your customers are buying is the product. I think there's a few other elements that matter. I mean, one is that putting a real company behind the product. So the product was able to mature and meet the needs of the customers, which included the regulatory requirements. Part of the thing that Snowflake, that we did well and I feel good about was we built the rest of the company up to be as high a quality as the product is. The product was great. We really had a lot of confidence in our product, but we also wanted Snowflake to be a great company for people to work with. And so the culture and the values were a very, very important part of that. I always focus on that and the importance of values. If you ask me what I'm most proud of at Snowflake, I'd probably tell you it's the values. It's probably the values of the company that I'm most proud of. And I think that's a large part of what's propelled Snowflake into the success that it is and has continued to help it be successful.
I've done a lot of interviews where I've said that how important our values are to me. And I think it's certainly a real answer, but it's also, I'll say, a safe answer. I want to see if I can get you to be a little more spicy by sharpening up Julia's question. I was referencing the Convert from Redshift playbook before. There was like 2017, 2018, somewhere around there. The Snowflake sales reps that I spoke to at the time, the frequency with which they would say separation of storage and compute was just, it was off the charts. Like that, you couldn't have a 30-minute conversation with a Snowflake sales rep and not have them say separation of storage and compute about 7 times, which, that was the core thing at the beginning. Now it's like many things, but that was like kind of the foundation. From my perspective, there was this window where if Redshift had managed to launch a service like Spectrum, or maybe let's say it
launched Spectrum, it didn't do anything, but that's okay.
A more user-friendly version of Spectrum.
If BigQuery, let me say it differently. If BigQuery had been on AWS, Snowflake would be a little company today.
Interesting. Huh.
I think it would have been much harder. Now, to be fair, you got to remember, maybe that's not true because BigQuery in 2017 didn't even was barely supporting.
It wasn't standard SQL.
It wasn't standard SQL. So you have to remember that it took them a while to actually turn that into a very good product. But, that was always the product I looked at and went, this is a product that has the characteristics that, fortunately, Redshift, because of its architecture, everybody was at how can AWS make Redshift as good as Snowflake? And they could start with the brand new sheet of paper and rebuild the product.
Yeah. So it really was that it was easier to rebuild the product from scratch, like i.e. make Snowflake, than it was to take an architecture that was fundamentally built around boxes and transform it into...
Well, we'll take a look. Let me give you an analogy here. So I work pretty closely with the Microsoft team right now. And so I know exactly what's happening with, the Synapse and their new Fabric work. And look at how long it's taken Microsoft to get, I think this new Fabric release that they just announced is their V3 release. I think it's a good release. I think it's the first release that can really compete with a Snowflake or a BigQuery. But look at how long it's taken them to do it. It's taken them a long time to get there. They didn't execute as well as they could have, but Lord knows they had the talent to start with. Lost a lot of it along the way. And they've rebuilt a lot of it too. It's hard. Where you end up. Well, this is a super important point, Tristan. This is relevant to the conversation we were having yesterday in prep for this. Where you end up in your product is very much a function of where you started.
Yeah. Mm-hmm. Yeah. I'm keeping some of my thoughts to myself, but it's like some of the challenges are still the challenges and some of the strengths are still the strengths of these companies. We're almost a decade out.
Still true today. And you can look at BigQuery and see its legacy and history as Dremel. Underneath it. It started as this big, not giant, proprietary query search thing for Google. And, now it's turned into a true SQL database. Look at Databricks. They started in the machine learning space. They're now just building out, really a competitive database offering. So everybody comes from, and meanwhile, Snowflake is just building out a competitive ML offering now. So
I've wanted to have you on the podcast for a while, but the reason why we're having you now is because you just wrote this book called The Datapreneurs. Do you want to just give a highlight on why you wrote the story and what it's about?
Sure. After I left Snowflake, I started mostly doing board work and also working with a number of different CEOs across the industry, including Tristan. I talk to Tristan every now and again. And I realized, that I had something to say. And I thought I tried to think about ways to get that down. I wasn't quite sure. So I began working with my co-author, Steve Ham, and this was the summer of 21. And we started seeing a narrative come out, and I said at some point, when we saw that there was a book in here, that I wanted to tell the story from the perspective of the entrepreneurs I've known, focused on data, or the data entrepreneurs. Realizing that I, as I said, even when I was at Microsoft, I was doing entrepreneurial things. I mean, I was working with great people that were doing entrepreneurial things, is what I should say, because I always facilitate these things. I mean, I'm not the brilliant engineer that makes the technology happen. I just help to facilitate the success of that technology. And so I've been working with these brilliant data entrepreneurs, and we had this idea. Steve had the idea of calling it Datapreneurs, and deciding to tell the story of the history of data and really the arc of data innovation that's happened over the last 40 or 50 years through the story of these people that have made it happen. And in the process of, while I was writing the book, the world just changed in a dramatic way because of the advent of these large language models and the potential for artificial general intelligence and everything else emerging in a much more short-term time frame. And so the book very much reflects that and talks about that. And I always had a little bit of that in the book. It was always going to be a little Isaac Asimov in the book, but I upped that a bit. I upped that because it seemed a lot more relevant right now. The issue of the laws of robotics seem much more important today than they did, say, 2 or 3 years ago.
You actually said the words that will take any conversation way off into the deep end. You said artificial general intelligence. We have on this podcast had plenty of conversations at this point about large language models. And since we released our most recent episode, I am very confident that every one of our listeners will have had dozens and dozens of conversations about ChatGPT and how it affects work and et cetera. I don't know that maybe we could spend a little time there, but what I would be very interested in hearing from you is, do you think the phrase artificial general intelligence has any place in pragmatic, business-focused conversation today? Or is it still a scientific curiosity that maybe one day we'll get there?
I don't think it's a short-term issue that business people need to be focusing on. So to answer your question, no, I don't think so. However, the horizon for it has moved in dramatically from where I used to sit. If you'd asked me in 2020 or 21 when we would have something like artificial general intelligence, I would have said maybe 2100. Okay. And so immediately at 2100, I don't care about that because I won't be here. I know that for sure. But now I think it may be 2030. And I'm like, holy cow. I hope to be here for that. And that, that was the awakening to me is that the horizon is moved in by a huge amount, at least from my perspective.
So still maybe too far away to put it into your financial plans, but something that's not totally in the realm of science fiction anymore.
Definitely not anymore. Yeah. I mean, I think we're seeing the intelligence of, here's the big thing, Tristan, which is just brand new. First time in my entire career, we have intelligence in these machines that has characteristics that, the ability to reason and think through things, which was never present before. That was never there before. And in essence, my history and focus has been on taking data and turning data into knowledge, and knowledge is basically data that has been analyzed and conclusions have been reached from it. And, that's what data analytics is all about, is to build knowledge about an organization. And when you can take knowledge that you have that you've built up through the data collection that you have and then the analysis that you've done from it, and you can combine it with these intelligence of these models, the potential for business is quite dramatic. And I think that's what we're going to see in the next 5 years. We don't need AGI to have massive business transformation because we now have the ability to more easily encapsulate knowledge and then take intelligence, which can run in a machine, and apply that intelligence to knowledge, including potentially the analysis of data, which is one of the most interesting characteristics of this. Finally, machines can actually do the data analysis for us, and we'll start to see that. I think BI is going to change dramatically in the next 3 years and we're going to move from the primary language of BI being SQL to the primary language of BI being English, with SQL as being the intermediate language that determines the actual query that's running.
Maybe let's go there. I think one of the overarching arcs of the book, as I read it, was we started very much in the relational world, starting with SQL. You talked about the opening chapter was the first modern database with Ingress. And of course, you talked about Snowflake. And then you moved to what you call complex data and how we need to think about working with a new data type. And I'm going to quote you here because it was a pretty strong wording, which is, SQL served us well, but the time has come to augment the new approach. The days of SQL dominance are numbered. So what does augment look like to you? You just mentioned English might be the new way to query data.
First of all, when I originally wrote that, I really didn't mean it. And when I first wrote those words, I didn't mean English augmenting it because it was before, it was honestly before the large language model.
Too much has changed.
Even though it was over a year ago, in other words, it was over a year ago before this major transition happened. But what I did see was the fact that the semantics that we want to express in our business environments are more complex than you can express in SQL. SQL, this is, and I do talk about this in the book, it's important to go back and look at where SQL came from. I mean, it was developed by IBM in the 1970s, in the mid 1970s. It was a database language that came out of that work that was focused on the new relational model, which was a mathematical model that Edward Codd had created. When Codd did the model, he determined that there was two distinct things. There was an algebra, which is a set of ordered statements that you can make where you run them in order and it will perform a set of operations. And there's a calculus, which is a set of unordered declarative statements that describe what you want to do. And Codd's law says that those two things are equivalent. They're semantically equivalent. And that's why essentially we have these query processors. I mean, in essence, SQL, it's not a pure calculus, but it is a database language that acts like a calculus where you describe what you want to do and the query optimizer does the how. Now, that language is not complete for relational semantics. And in particular, you cannot model, what you can model in SQL is tables and data around tables. But if you look at the real world, a table is not necessarily the best representation for data. And in fact, people are talking about different kinds of databases, knowledge graphs, where you abstractly define all of the different concepts and their relationships, and also potentially the equations that connect those together. In other words, the business model. So what I think is going to happen is we're going to start to see languages that allow you to model the full business and the full business semantics. And that will become the underlying semantic model that allows us to create a data model from that. And I will go further and say that I think that data engineering will evolve over time to become business engineering. And that will become really the new discipline. I think by 2030, that will be the discipline for sure. Probably sooner.
Oh, geez.
Did you script him?
No. I just okay, there goes the rest of our time, just digging into that set of statements.
I did that on purpose, Tristan. I did that. Remember I said, tell me about your semantic model and where we're going in the semantic model.
Well, okay, fine. And we can go there. But the thread I want to pick up is right at the very end and the evolution of data engineering. My belief, and I was actually on stage at Snowflake Summit and was talking to a room full of CDOs on this exact topic, where I know it's overplayed and maybe you can tell me a better analogy to use. But I was talking about how far away data engineering today is from the Apple ecosystem, where in the Apple ecosystem, you just totally forget about how the dots are connected. You boot up a new iPhone, and in order to transfer your data from the old iPhone, you hold them close together. It's I literally don't know how any of this works. It just kind of happens. And data engineering, you're just operating forklifts and dump trucks, and you're just it's so low level today still. And even to a certain extent, I think dbt helps you move in the right direction towards this today. But I think we also still have a long way to go to get people out of the operational characteristics, because my belief is that the actual high value work, talking about AGI, what's the last stuff that is going to be replaced? It is, in your words, the business engineering. That is where we should be spending our time, not in the well, it was in a Parquet file in this S3 bucket, and now I need to. That's really not a good use of anyone's time.
Yeah, and look. See, my view is this, again, there's an arc of data innovation, and that's what the whole book is about. None of the things we're talking about, the idea of discussing business model engineering, which is what we're talking about right now, that wasn't possible until you had actually gotten data engineering to work. And if you go back before the modern data stack was created, data was scattered everywhere. And there was no, I mean, if you looked at what a data engineer or a data scientist job was, mostly it was wrangling data and finding the data and getting it. Hopefully, in most organizations, the modern data stack is simplifying that process for people. So putting it all in one place, it's beginning to put appropriate access control on top of that. And so now we have this entire ontology, we have this entire set of data that is a corpus that is incredibly valuable for an organization, and it's all contained within one system. Now we can begin to do these higher order concepts. It was necessary. I mean, when I was at Snowflake, I knew something like dbt had to exist because it was absurd that people weren't using SQL to do most of their data modeling. People were using Spark and all this stuff. We needed a tool like dbt, which allowed people to bring that into the data processing stack that was created as a part of the modern data stack. The next step is in my mind, is to define the higher order semantics and automating much of those processes. I continue to believe, I mean, I really believe this in my heart, that if you define the business model and you have defined the business semantics and that is stored in a knowledge graph, the data model can be derived from that. And I actually think that's the long-term right way to do it, is you define the semantics and then the data model becomes a desired state management that you build off on that. In general, I think we will have these semantic models that define the business, the desired state of the business, that will cooperate with many different systems to ensure that the state that is defined by business model, the desired state, is the actual state that is running inside the system. That's a fundamental tool. I learned that concept of desired state management I was taught by Anders Winberg, a brilliant technologist, a technical fellow at Microsoft that explained that to me in systems management in roughly 2003, 2004. And that was the technique that we used.
Julia, it sounds a lot like the way we're thinking about orchestration.
Yeah, I was going to jump in. It feels like the industry has gone from the imperative world where you have to define every task to get from point A to point B, and the tools to do that are really hard. Like you start off with Hadoop, that was really difficult to manage. You had this like massive hammer to do these simple tasks. And then over time, like people just start trusting more in their machines or software to do some of the heavy lifting and leave the human part to the humans. And, you know, in this case, it's really understanding your business and the relationships. And it's a fundamental like trust thing where you have to like crawl before you can walk. People have to like do the steps themselves, believe it works, understand the pain and frustration, and hopefully people will get closer to the declarative approach and kind of welcome software to just take the hard part out of this data engineering and data work.
Can I make the bear case on this? Because I really do believe that this is the thing, but that's really boring if all three people on a podcast just agree with each other. In talking with, hopefully we get this episode out soon because otherwise it'll age poorly, but just because I am just getting back from Snowflake Summit, had conversations with a lot of data leaders, and the human element of all this is very front and center to folks who are trying to shepherd this change in their organizations. And I think that it's possible that all three of us have a little bit of a technology bent to our mindsets. Like, what is possible? How can we create that thing faster? So one of the things that was like so striking to me is that over and over and over again, I heard folks saying it is totally possible for teams in my organization to create better architectures, to do more reuse of whatever the thing is, in this case, dbt models. But sometimes, because those teams are located in different parts of the organization, it is just easier for them to recreate their own thing over here that is unrelated to the other thing that's already created, as opposed to making a really tiny change in a PR to the thing that already exists. While completely agreeing with you that this potential future state is totally achievable, I wonder if you think that the complex human systems required to get there are going to actually manifest in reality.
The human systems follow when the technology offers advantage to the humans. To human. It takes time. Right now, if you ask IT managers, I mean, I asked this question late last year. I haven't asked it since. Of a bunch of IT managers, I had about 100 of them in a room, how many had adopted one of these modern data stack platforms? Only about 30% of the people said they had. So you're still, even in 2022, you still even have a significant number of major people that have not moved on to these platforms yet. And we're still in that adoption stage. And so that's the really important thing to remember. People move along on these things. Running companies is all about people, and everything you do inside an organization is all about the cultural side. That's why I always come back to values. How values are very important. I always start with values. I like to end with values, and in between, it's always about, people and the behavior associated with it. And they change over time, but they do change when there's value to them. And so if, what I'm describing will not be accepted if it's a pure black box.
Mm-hmm.
It will not be accepted if it doesn't do the right thing. I mean, let's start. First of all, this stuff has to work, and we aren't there yet. So we're a few years away. I'm still trying to make sure we can build the damn database that can store this thing, right? I mean, there is no fully commercially shipping relational knowledge graph system that can do what I'm describing as a standard database. There are a number of different databases you can use for parts of it. You can take a graph database like Tiger or something, or Neo or something. You can do pieces of it, but you can't really build the whole thing. And, one of my focus has been on making that new kind of database, a relational knowledge graph exist. One of the reasons why I think it's so important is a knowledge graph provides you a sheet of paper, in essence, where you can have commonality of a conversation. People can look at it and understand what you're talking about, and machines can look at it and understand what you're talking about. And a lot of the problems we have with these language models, we can write this stuff in English, but we better make sure that the machine is doing what we think it's doing. I'm now thinking that there's almost 3 levels of this. There's common English, which is very ambiguous. There is some kind of canonical English that describes exactly the process you're doing in a way that can be translated semantically directly to the underlying logic. And I think there's a visualization of this. I mean, there's a lot of things that will help us. We can have pictures, we can have words, and then we can look at the actual underlying code in the languages. And one of the things that I have come to the conclusion of, as I talk about building these business models, my last 2 or 3 years, I've come to the conclusion that they're too hard for people to do. That these business models of companies,
oh, interesting.
They exist. Where does a business model of a company exist? Well, first and foremost, in the applications that run the company. And there are typically hundreds of those, right? It exists in the business analytics side and the analytics tools that people are doing. And then most importantly of all, it exists in the heads of many people. And it's also documented in Slack messages and an occasional bulletin board thing here and there or whatever. It's all over the place, in other words. So I think there's huge value to building a single canonical description of the business, the sales funnel, everything else, that both people and these new language models can work off of. And that's, to me, a very important thing.
That's very interesting.
And those language models will help create it, by the way. They will help create it because I think it's too complicated to be created by just people.
I want to ask this question. We're almost out of time, so maybe a short answer. But it seems reminiscent now where enterprises are a bit fearful of sending their data to the third-party cloud-hosted LLMs like OpenAI. They're not comfortable sending their data. Is that similar in your mind to how the early days of Snowflake, where Goldman Sachs said no and eventually they came around? Or what will it take?
You bet.
Yeah.
Well, look, I mean, what it took literally was to win the financial service industry, we set upon winning Capital One. That was our goal, was to win Capital One. They were the most advanced financial organization on the cloud. They were the first to adopt the cloud and the most committed, certainly. And, they were on AWS, which was our primary cloud. And working with Capital One was incredible because, at first they were committed to, they're very strong Amazon customers. So they were very strong on Redshift. And, we were aware they were having some challenges on Redshift. So we allowed, we gave, there was a little time involved where they, had to figure out what was right for their company. And then, I wound up together with a number of my engineers meeting with Capital One, and really they specified what turned out to be the product they deployed, the virtual private Snowflake product. I mean, that product was spec'd. I can tell you that product was created on an airplane from San Francisco. I mean, I had the PowerPoint slides. I was flying out to DC to meet with them. And I described the whole product because I'd met with Capital One once and learned what they really needed. And then I literally, my program manager side sort of specified all the products. And then I called my team when I landed in DC and said, okay, this is what I'm going to present tomorrow. Tell me if I'm way off base. And they corrected me on a few things. And that became the initial definition of the specification. And, really, there were really key things that any place where a key exists in memory, it has to exist in a virtual machine that is isolated and, is not shared in any way. All the data had to be, stored in a place where Capital One had control and all the metadata as well. And that's what, resulted. And we needed to do multi-region failover. That was the other big thing, the ability to support business continuity. And so that eventually became the product spec that turned into both virtual private Snowflake and then really then that also was fundamental in the business critical product. And that defined what enterprises could use. Now, what's interesting, I'll keep going, is that the architecture of Snowflake, which is, you run Snowflake inside a Snowflake VPC, that architecture is somewhat problematic for some classes of customers with the highest level of security requirements, where they want to run it inside their own environment. That's certainly true for the federal government. But it's also true for some enterprise. It turns out I've learned there's another class of enterprise that's maybe even more sensitive than financials. And that's the enterprises like Raytheon and Northrop Grumman, all the companies that do government contracting. And so the architecture, I think that people are moving more and more to an architecture where you run inside the customer's VPC. And I think Snowflake will do more of that too now that they support Iceberg, where the data is sitting inside a customer environment. So you learn. All of this means is you talk to your customers and you learn from them. That's all I just said, right? I just said I met with my customers and I listened to them and we learned from them. That's all.
From one product manager to another. You did a great job.
Thank you. It's the most fun thing in the world, in my opinion, is building products to meet the needs of customers. I can't imagine anything more fun.
We're going to wrap up. This has been a really awesome episode, but we ask this to all our guests. Looking 10 years out, what do you hope will be true for the data industry?
Actually, I hope that we have moved, I hope we've moved beyond worrying about the formats and all these things. I really hope we are moving to become business. I hope the data industry will become the business engineering industry. That's what I hope, is that we move to and up-level our conversation to focus on the real needs of the business, and that the systems become smart enough to do a lot of that grunge work for us. And I'm very confident, actually, it's going to happen. I now can see the path. I knew it had to happen. 3 years ago, I knew it had to happen. I knew a bunch of this machine learning stuff would have to play a role, but I didn't understand how, because the technology had not advanced at that point. Now it's totally clear. It's just a matter of making it happen. Still a lot of work.
Yeah, I want that too.
You're saying you don't want to spend any more time talking about Delta versus Hootie versus Iceberg. That's not...
Well, I love that, Tristan. That's my world. I'm a plumber. I've always lived in that world. That's the world I don't want my customers thinking about.
Yeah.
I don't mind.
I'm with you. Thank you. This has been a lot of fun. We will schedule you for another episode in 2030 when AGI is here, and we can do a recap on that.
You'll be talking to my avatar at the time.
All right. Thanks, Bob.
Thanks.
The Analytics Engineering Podcast is sponsored by DBT Labs and is hosted by Tristan Handy and myself, Julia Schottenstein. Have comments, questions, or guest suggestions? Email us at podcast@dbtlabs.com. Our producers are Jeff Fox and Dan Poppy. If you enjoy the show, please drop a review or share it with a friend. Thanks for listening.